Assalamualaikum everyone. Welcome to our very first virtual class. Now today's lesson is on topic 1, which is Introduction to Statistics. Now I hope that you will use these lectures together with your notes, lecture notes, and your required textbook. For those of you who have asked me in Google Classroom when to get the lecture notes, well, the notes will be arriving at my office tomorrow morning. So if you'd like to come and collect it, you can come by maybe sometime in the afternoon or after Friday prayers, okay? Right, so let's start with what is statistics? Statistics is defined as the science of collecting, organizing, presenting, analyzing, and interpreting numerical data. Normally, the results that we get from this exercise, we use them to make good decisions for ourselves. In other words, we can say that statistics is a tool to make effective decisions. Now let's focus on these 5 elements of statistics. Now, in order to help you understand them better, why don't you relate them with the assignment that you're about to do? You remember the assignment that I gave you? The first thing you needed to do is to collect data. This is because data doesn't just appear. You have to go out there and collect them yourselves. There are generally 2 types of data that you can collect. One is known as primary data. Primary data is basically data that you collect from surveys or interviews or experiments. The second type of data is called secondary data. Now, these are data that you collect from published reports or from organizations or government agencies or even companies. In other words, these data are already in existence and all you have to do is get permission to use them. Now, once you have collected your data, you need to organize them in such a way that makes sense to you. How? Well, you can organize your data by way of tables or diagrams or charts or even numbers. Now, after you've organized your data, what you need to do next is to present them to your audience. Now, in your case, your audience is me. So you must make sure that you present your data in an interesting manner, as well as in a way that makes sense to the both of us. Now, it's not enough just to present your data. You must understand what your data is trying to tell you. This is basically analyzing your data. Now, once you know what your data is all about, you'll be able to use it to answer any questions or any problems that you were looking for. Now, this is basically interpreting your data. So I hope you understand the definition of statistics and understand especially these 5 elements of statistics, okay? Now, next, why don't we move on to why do we need to learn statistics? There are plenty of reasons, of course, but here I would like to highlight only 4. The first one is numerical information is everywhere. In other words, if you look around you, you will see numbers everywhere, guys. This is true. If you go to Giant, along those aisles, you'll see numbers, maybe in the form of prices. And if you want to go shopping, you might see there are certain percentages, sales, whatever. Again, numbers. If you read the newspaper or the magazine, you see plenty of numbers in there as well. When you want to do your course registration, also numbers. When you see how many sections are still available, how many students are required to fill in a class, for instance. Again, all are numbers. So, in other words, we live in a world ruled by numbers. So if you don't like numbers or if you're afraid of them, that's a bit, that's too bad, isn't it? So because we live with numbers, we need to know how to read them. We need to understand them. That is why we need to learn statistics. Now, secondly, when we learn statistics, you'll be exposed to many statistical techniques. Just from the definition as mentioned just now, see, when you want to present and analyze them, you'll be exposed to many ways in order to understand those data. So once you understand how to read the data, you'll be able to use them to make good decisions that may affect your lives. Okay, what are these decisions, for instance? Okay, let me give you an example. When you work later, maybe one of the first things that you want to get for yourself is an insurance. Now, the calculation for insurance premium is based on many factors, all of which constitute of numbers. Maybe it depends on your age, your life expectancy, your salary or budget. See, all of those are numbers. So if you know how certain things are calculated, maybe it can help you make better decisions as to which insurance you want to get. Besides that, whenever we face haze, every year, you may be able to read the API index, the air pollutant index. See, so those are among the reasons as to why learning statistics may be helpful for you. The third reason here I would like to highlight when you're involved in business. Now, in the future, you may be working for others, or sometimes you may own your own businesses. But whichever way it is, you will be involved in, or you will be facing a lot of information. So the minute you have all of this information, you need to find a way to understand them. So how do we understand this information? Again, go back to the definition of statistics. You collect all the information around you, you organize them, and then you present it to your boss or maybe for yourself so that you can understand and interpret and answer whatever problems that you're facing. So that in that way, statistics will help you make good decisions for your businesses. Here, do you notice that the word make decisions appear many times? So as you can see, this is what I've been trying to highlight earlier. Statistics is basically a tool to make good decisions. So yes, so that is why we can see the word making decisions appear many times. Okay, the next or the final reason as to why we learn statistics that I'd like to share with you is in your own perspective as graduates. Now, statistics is one of the quantitative subjects which many students take, and I tell you it's very beneficial to learn this course because it will increase your marketability and also perhaps some chance of getting a good job. Now, I'm not exaggerating, guys. Here I would like to share with you a study conducted by Appleby in 2014. He shares that employers value 7 basic skills in fresh graduates. Now, if you noticed the one in bold here, critical thinking and research skill, this skill you can harness, you can improve by way of quantitative courses. So yes, you may not like to admit it, but the more quantitative courses you take in university, you are more trained to think analytically, and this will in a way make you very, very marketable, especially if you score in those subjects. Okay, let's move on to the different types of statistics. There are generally 2 types of applied statistics, which are descriptive statistics and inferential statistics. So what is descriptive statistics? If you look at the term descriptive, the root word is describe. You know what describe is, right? If you're asked to describe a chair, for instance, you may say that the chair is heavy or the chair is made from wood. So in other words, descriptive statistics is basically summarizing and presenting the data in such a way that is easy for your readers to understand. And if you recall the definition of statistics earlier, when you want to present your data, you can do so in 3 ways. One is to put them in tables, you can put them in charts or diagrams, as well as in numbers. So this is basically descriptive statistics, which is the definition of statistics in itself. The second one, which is inferential statistics, this relates more to the objective of statistics as a whole. Now, inferential, the root word is inference. Making an inference is simply trying to generalize something to a much bigger picture. For instance, here, let's say you have a big group of people. You would like to say something about them. Unfortunately, you're not able to ask each and every one of them their opinions. You're only able to get the opinions of a selected few here. So making an inference is simply from the data or from the information that you get from this small group of people, you want to generalize it to the much bigger group. This is basically making an inference. Okay, so in other words, here's the definition. When you can only collect data from a small portion of a group and you want to generalize it to a much larger group, that is basically inferential statistics here. So these basically are the 2 types of statistics that you will learn throughout the semester. Let's move on to variable and data. Is there a difference between the 2? Well, many people use them interchangeably, but actually there is a bit of difference. Variable is a characteristic of something that we are interested in, whereas data is the collection of items or facts and figures associated with that variable. For instance, if you are interested to ask people their ages, now age is a variable. The collection of age from 5 different people, for instance, 20 years old, 25 years old, 10 years old, 45 years old, and 30 years old, all of those numbers are data. Okay, so as you can see here, variable, the root word is vary. So you know what vary means, right? Vary means it's always changing. not constant. So for any characteristic of interest that you ask people or anyone, you'll be able to get many, many different numbers or values. So I hope you understand the difference between variables and data. Now, these are other important terms I believe you should know in statistics. Now, you have been introduced to the term population just now. Remember when I drew this big group of people? Now, this is a population, which is a collection of all items and individuals of interest. But if you can't get information on the population, sometimes you can get a much smaller or a part of the population, which is called a sample. Parameter is the numerical measure computed from the population. So if you are able to get information from your population, so that number is called a parameter. But if you're only able to get a sample, the calculation for that sample is called a statistic. Now, please don't be confused between the word statistic and our course statistics. Okay, statistics is always plural. Okay, what it means is we are dealing with a lot of numbers, facts and figures, because what is the use of only one number in decision making? Okay, whereas here data set is a collection of all of the data that represents the matter of interest. Now you may have noticed whenever we say the word data, data is always plural, guys. The singular form is called a datum. Okay, so whenever we talked about variables and data, we're always looking at the plural side of things. Moving on to the types of data. There are generally two types of data, which are qualitative data and quantitative data. What is qualitative data? Now, from the word qualitative, the root word is quality. What is quality? It's basically data that you cannot measure numerically, that you cannot put numbers to them. Instead, we use labels or names to identify the characteristics of those data. In some other textbooks, qualitative data is also known as categorical data. Now, a variable that has qualitative data is called a qualitative variable. Now next, what is quantitative data? From the word quantitative, the root word is quantity. So quantity means you can count them, right? You can measure them, right? So in other words, data that can be measured numerically is quantitative data. And a variable with quantitative data is called a quantitative variables. Now for quantitative data, it can further divide it into two, which are discrete and continuous quantitative data. What is a discrete quantitative data? It's basically data that can take only certain values, and there are usually gaps between them. For instance, the number of internet users in Malaysia. Perhaps there's 1 million or 1.5 million. Or how many active social media users in our classroom? There are 150 students. Maybe there are 100 of you who are active on social media, or only 50. Can you see the numbers? 50, 60, 100. So all these numbers are certain values. There are breaks between them. Another type of quantitative data is continuous data. These are basically data that can take any value within a specified range. For instance, the time taken that you do for a particular exam. For our statistical methods, it's 2.5 hours. A student may be able to complete the exam in 2 hours. Some may complete it in 1.5 hours. Some may complete it in 2.5 hours. Whatever the number is or how long it is, it's still limited to 2.5 hours. So this is what it means. Continuous data is any value but within a specified range. Okay, so I do hope you understand what it means by qualitative and quantitative data. Now let's move on to the last part of our first lecture, which is levels of measurement. Now, after we collect our data, we would like to organize them in such a way that makes sense to us, right? So when we want to organize our data, we can actually classify them into 4 levels or scales of measurement. They are known as nominal, ordinal, interval, or ratio levels of measurement. So let's look at them in turn. What is nominal level of measurement? Now, whenever you have data that you cannot measure by numbers, you can always use names or labels to describe them. So this is basically nominal. levels of measurement. In fact, if you want to remember further, nominal is derived from the Latin word nom. Nom is basically name in Latin. All right. Okay, so nominal level of measurement is the lowest level of measurement because, well, later when you compare it with the other levels of measurement, whatever data that is measured nominally, you cannot exploit it. You can't change number. You can't do any operations on them. You can't multiply, you can't divide. So in other words, whatever it is what it is. Okay, so that is why it's called lowest level of measurement. It's nothing to do with physical strength. Okay, besides that, nominal level of measurement is also used to classify qualitative data into categories, as I mentioned to you before. And the thing with nominal levels of measurement is you cannot arrange them in any way. For instance, gender. You know there's male and female, but there's no way for us to say which is better. You can't say male is better, or you can't say female is better. So because there's no way for us to determine which is better, that is why it falls under nominal category. Now let's look at the second level of measurement, which is ordinal. Ordinal level of measurement is just like nominal in that the data are basically described by names or labels, but this time around we can order them. We can arrange them in some rank. All right. So for instance, let's look at here the example, size. You know the sizes that we have here? S is small, M is medium, and L is large. In a way, we can rank it, right? S is the smallest size, followed by medium, followed by L, or large. So this is what it means by we can rank those data. Now let's look at the third level of measurement, which is interval. Now interval is just like ordinal, where we can rank the data in some manner, but this time around, not only we can rank them, we can also calculate the difference between the data values. For instance, let's look at the size just now under ordinal. The size in ordinal is simply SML. We know S is small, M is medium, L is large, but we do not know how much bigger or how much smaller the sizes are. But here, in contrast, the stress size, if they are expressed in numbers such as size 2, size 4, size 6, size 12, you know, this is normally the sizes in British, for British clothes. So we can actually calculate the difference between the sizes. Okay, so that's the main difference between ordinal and interval. Remember, both of them we can rank, but only the interval data we can calculate the difference between the values. Now let's look at the last level of measurement, which is ratio. Now ratio is similar to interval, very similar. Okay, similar in the sense that they are both used to measure numerical or quantitative data. But the difference here now is for ratio, there is a meaningful zero starting point. Unlike interval, what it means is when we say something is zero, it literally means nothing or the absence of the characteristics. Okay, like for instance, monthly income. If someone says, I have no income, I have zero income, what it means is that person literally has no income, literally has zero balance maybe in their bank account. Next example, number of students queuing. If I say there are 5 students queuing, there are 5. But if I say there are 0 or there's no student queuing, it literally means there is no student there. So this is the basic or the most important distinction between ratio and interval. Because sometimes when you say something is 0, it doesn't really mean 0. For instance here, dress size. Do you know that there's actually a dress size 0? There is actually. Who wears size 0? Supermodels or extremely thin girls or guys. Okay, so here what it means is this size 0 doesn't mean that that person has no body. There is still a body, but then it's just size 0 to show that it's a very, very small size. I hope you understand this. Okay, if you don't quite get this, feel free to read about it in the textbook or look at it in other references. All right. Okay, here I would like to share with you some sort of illustration with regards to the levels of measurement. I hope this can help you to understand levels of measurement better. Here's nominal, the lowest level of measurement, which is just the name or the labels of the variables. Now, if those names you can rank them, it becomes ordinal in nature. Now, for something which you can name and you can order, and this time around you can actually calculate the difference between them, or you can find the proportions between them, it becomes the interval level of measurement. And finally, the highest level of measurement, not only you can name them, you can order them, you can calculate the difference between them, there's also a meaningful zero, it becomes ratio. So I hope with this diagram you can understand levels of measurement better. Okay, so why is it important for us to know this level of measurement? Well, very easy, because we have a lot of data, right? And the thing is, in statistics, we have many different tests too, and we cannot apply all tests or any test for any sort of data. You must know the type of data so that you can know which test is most suitable to be performed on those data. And besides that, of course, the first one here, when you know the level of measurement, it can help you to decide on how to present the data. For instance, quantitative data, you can present them in pie chart, you can present them in histogram, whereas qualitative data, you can present them in a bar graph or bar chart. Okay, so all of this is available in your lecture notes, so feel free to read them. All right, so that's it, basically, our short virtual class. It's only about 21 minutes. I hope you could understand my lecture. It's actually very difficult for me to explain it without seeing you in person. And you may think it's easy recording yourself, but actually it's not. I really very much prefer to have a live class where I can interact with you in person. So anyway, now I hope you guys will go and try out the exercises at the back of topic 1, which is on page 2 and 3. Please do try out the exercises, and we will discuss the answers when we meet on the 25th. Okay, all right, so I hope you guys take care of yourself during this outbreak, and drink lots of water, keep yourself safe, and try to wear masks whenever you can. All right, assalamu alaikum.